Hi, my name is Darshan and I'm an online tutor of math and physics. In this video, we're going to talk about FRQ number 3. So this is part B of AP Calculus AP Calculus BC 2023. Calculator is not allowed. That's an interesting thing. The first question is based on slope field and differential equation. So let's read this out. Okay, says that a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of the milk at time t, where mt is measured in degrees Celsius and t is the number of minutes since the bottle was placed in the pan. All right, okay, makes sense. M satisfies the differential equation. So this is the differential equation, not the m, right? This is the rate at which the temperature of the the milk is changing with respect to time. So dm over dt is 1/4 of 40 minus m. At t equal to 0, the temperature of the milk is 5, and it can be shown that m is less than 40 for all values of t. So this is something which is given in the question, of course, that m is always less than 40 for all t. The slope field for this guy is shown. So this is the slope field, and we need to find a solution curve through the point 0, 5, which is right over here. That's pretty straightforward. You just have to track the slope field right carefully, and obviously it makes absolute sense that there is an asymptote at y equal to 40, because this can never reach 40, right? It's like just taper about 40. So it's gonna go like this. It's just gonna follow the track. So it goes like this, slows down and almost tapers like this over here about m equal to 40. This is obviously 40, which makes perfect sense. Yeah, so this is how the slope field is going to look like. That's pretty straightforward, right? Okay, all right. The next one is use the tangent line approximation, or the tangent or the line tangent to the graph of m at t equal to 0 to approximate the value of m of 2, the temperature of the milk at t equal to 2 minutes. So this is the linear approximation, tangent approximation, known by a couple of names. But all we have to do is find the equation of the tangent at t equal to 0, and we very well know that at t equal to 0 the value of m is 5, right? Because the 0, 5 is a point on it. So at t equal to 0, we very well know that the value of m is 5. So this is the so-called point. We need to get the value of m prime 0, or maybe dm over dt at this particular point. So we know that dm over dt is right here in front of us. That is 1/4 of 40 minus m. And what is the value of m? It's 5. So I'm going to plug in 5 here. So that's going to look like 40 minus 5, and there's a 1/4 already outside. So that's going to look like 1/4 of 35, or maybe 35 over 4. So we got the slope, we have the point. So it's very easy for us to write the equation of tangent, a little bit SAT coming back in. So we know that the equation of tangent as per the point slope form is given by y minus y1 equal to m times x minus x1. So this is going to look like y1 is the y coordinate, which is clearly 5. M is the slope, which is 35 over 4. And x1 is right over here, that's 0. So y minus 5 is equal to 35x over 4, and they need the value at a specific value of x, or I mean t. So t and x are equivalent. That is the independent function. So t equal to 2. So all we got to do is plug in the value of t as 2, or x as 2, which is right over here. Calculator is not allowed, of course. So let's reduce this. 2 times 2 is 4, and 35 over 2 is 17.5, and adding 5 both the sides, we have the value of y as 22.5. And what is y? Y is, after all, nothing but m. So this means that the value of m of 2, that is the temperature of the milk at 2 minutes, is actually equal to 22.5 degree Celsius. Units are important. So degree Celsius, that is our final answer for part B of this question. I hope it makes sense. Let's move ahead and try the next part. Here they are asking us the value of the second derivative of m with respect to t, and use this guy to determine whether the approximation of the last question is an underestimation or an overestimation for the value of m2. So we should know this, that whenever you draw a tangent line anywhere, and there can be two situations, either the function is concave down or the function is concave up. Let me make concave up first, like this or like this. So let's say you're drawing a tangent at some point, and it's intuitive that if you draw a tangent at a point where the function is concave up, obviously the function obviously that the value at the tangent is here and the actual value is here. So you are underestimating, right? You're giving an underestimation of it. So for a concave up function, you basically give an underestimation, and likewise for the concave down function, obviously your tangent's value is right here and the functional's value is right here. So you're giving a higher value, you're overshooting it. So it's an overestimation. So if we get the value of d square m over dt square as negative, that's concave down. So accordingly, we can answer this question. So all what matters is to find the double derivative of this guy. So let me just go ahead and do d over dt of this thing. So that's going to be d over dt of 1/4 of 40 minus m, correct? Be careful over here. Why? Because I'll tell you in a minute. 1/4 comes out d over dt of 40 minus m. So 1/4 remains as it is. What is the derivative of 40? 0. And what is the derivative of m? Remember, that's not 1. That because that is a derivative with respect to t, we got to find the derivative with respect to t. So that is just dm over dt. Right, this is what we have to be careful about. So this is negative 1/4 of dm over dt. That's what we have. Running a little short in space. Let me separate my work over here. I hope I can do in this much space. Okay. And what is dm over dt, by the way? That is already given in the question, right here. This is dm over dt, so I'm going to plug that back in over here. So it's going to look like 1/4 of 40 minus m, and 1/4 times 1/4 is 1/16 along with a negative sign outside. So that's going to look like negative 1 over 16 times 40 minus m. Remember, it was already given in the question. I'm just going to go back to the original, the initial information of the question. I've already highlighted that the value of m is always less than 40. If it is always less than 40, can we say that this guy is always positive? 1 over 16 is positive. Positive times positive is positive. And this negative is going to make everything negative. So can we say, write an expression? So by the way, this is the expression first. I'm going to box it up, and then they want us to use this. So we clearly, I think you know what I'm going to say now, that d square m over dt square is less than 0, which implies that the function is concave down. And courtesy to the green part, which we already did earlier, concave down means it's an overestimation. So overestimation. What we estimated in part B is actually an overestimation of the actual value of m2, right? It's an important question. This concept in itself is quite important, so please make sure you understand this. I think this is the last part. Yeah. So use the separation of variables to find the expression for mt. Okay. The particular solution. Okay, all right, this is just the solution of the differential equation. Pretty easy differential equation, just the separation of variables. So dm over dt is going to be 1/4 40 minus m. I'm going to rearrange or redecorate this a little bit, bring all the family members of m on one side and t over on the other side. I'm going to do that in steps so that you can follow. Multiplying 4 both the sides, so 4 dm over dt is going to look like 40 minus m. I'm gonna multiply both sides with dt so that dt goes over on the other side. And last but not least is obviously dividing both sides with 40 minus m, so that all the family members of m are on one side and t is on the other side. And all I have to do is integrate or find the antiderivative on both the sides over here. All right, excellent. So let's move ahead over here. Let me separate my work. So what is the integration of 1 over 40 minus m? If you cannot figure out right away, obviously that's going to be log. But if you think you are getting a little bit confused, use a u substitution. It doesn't harm. So 4 minus m is u, which means that minus of dm is du, which means that the value of dm is negative of du. So the left side integration is going to look like 4 times dm will be replaced by negative of du over 40 minus m is just u, and dt is just dt. So this is going to look like negative 4, and what is the integration of 1 over u? That's natural log of absolute value of u, and that is equal to t plus some constant of integral c. Obviously I want my answer to be in terms of original variable, so I'm going to plug u back in as 40 minus m. So that's going to look like absolute value of 40 minus m is equal to t plus c. Okay, but I need c as well because the initial condition is already given to us. All right, running a little short on space once again, so I hope I can do this in this space. Okay, so it's already given that at t equal to 0, m is 5, because that is the meaning of m0 equal to 5, right? That when t is 0, m is 5. So I'm going to plug that back in over here. Over where? Over here to get the value of c. This is going to look like negative 4 ln of 40 minus 5, which is 35, and absolute value of 35 is just 35. So I'm not going to write absolute value. Is 0 plus c because t is 0. So the value of c is negative 4 ln of 35. So all we have to do is plug this c back in over here to get the value of m. So that's going to look like negative 4 ln, let's change the colors, shall we? Negative 4 ln 40 minus m is equal to t minus 4 ln 35, but do not leave the answer like this because they need the expression of mt. So they want you to isolate m entirely. So I'm going to erase this part over here. I hope you have written this down if you were writing anything. So I'm going to rewrite that because that's going to look like negative 4 ln of absolute value of 40 minus m. And don't you think absolute value can be dropped? Why? Because like we said, m is always less than 40. So 40 minus m is always going to be positive. So I'm just going to drop the absolute value sign now. So that's going to look like 40 minus m is equal to t minus 4 ln 35. I'm going to add 4 ln 35 over on both the sides. So that's going to look like 4 ln 35 minus 4 ln 40 minus m is t. I'm going to divide both sides with 4, or maybe take 4 as a common factor. So 4 ln 35 minus ln 40 minus m is equal to t. I'm going to divide both sides with 4. So ln 35 minus ln of 40 minus m is equal to t over 4. I'm going to multiply negative on both the sides. I'm doing that for a reason. Ln of 40 minus m minus ln of 35 is equal to negative 3 over 4. And log a minus log b is log a over b, right? So I'm going to write this as ln of 40 minus m over 35 is equal to negative t over 4. All right, got to make some more space over here. So let me clear this part. Okay. So, okay, how to take anti-log both the sides? We just keep the inside guy as it is. So 40 minus m over 35 remains as it is. And the other guy is just raised to the power of e. So this is e raised to negative t over 4. Multiplying 35 both the sides. So we have 40 minus m is equal to 35 times e raised to negative t over 4. And finally, if we rearrange, the value of 40 minus 35 e raised to negative t over 4 is going to be m. Finally, the value of m of t is 40 minus 35 e raised to negative t over 4. I hope I have not made any calculation mistake. Let me know what you think about this. If you're getting a different answer, please let me know in the comment section. So using the separation of variables, I find the expression for m of t, a particular solution, keeping in mind that m of 0 is 5. Right, this was the last part of this FRQ. I hope this makes sense, and if this video was helpful to you, please subscribe to my channel. Bye bye.